Hello everyone. Hello everyone. Okay, few students are still coming. Hi. Hello everyone. Hello Patel. Hello Anuj. Hello Patil. Official ringtone. Funny name. Hello. Hello Pramod. Hello Ravdi. Hello. Okay. Today in this lecture we are starting engineering mechanics. We are starting engineering mechanics. Good evening. Hello. Now let's come to the subject. Hello everyone. Now firstly I will introduce about Ekeeda. Hello. Ekeeda is the largest online learning platform for engineering students. Ekeeda provides almost all the courses of engineering, and this year Ekeeda is launching GATE examination also. Now, for a live in GATE course, Ekeeda is providing recorded lectures also and live doubt clearing lectures also. Also, we are providing you test series in the same course. यस पूरा कोर्स होगा बेटा. इंजीनियरिंग मैकेनिक्स का पूरा कोर्स होगा. डोंट वरी अबाउट दैट. Not only engineering mechanics, each and every subject in detail we will provide you total course. That too again recorded lectures, live doubt lectures and test series also. Don't worry about that. Yes, this is the first lecture. Now we are starting. Now concentrate on the screen. We are starting the lecture. Now engineering mechanics. Basically students, this engineering mechanics itself is a very vast branch of engineering. This is a very big branch of engineering. And in engineering mechanics, basically there are two subjects or there are two branches. That is solid mechanics. First is solid mechanics, and other is fluid mechanics. That is mechanics of fluids or fluid mechanics. We can say that fluid mechanics or mechanics of fluids, right? These are the two major subjects of engineering mechanics. Now here again in solid mechanics there are two major subjects. Number one is mechanics of rigid body. Mechanics of rigid body. Mechanics of rigid body. This is one of the major subject in solid mechanics. And other is mechanics of deformable body. Mechanics of deformable body. Deformable body. Now see, mechanics of rigid body. Here in this first subject, that is mechanics of rigid body, we are going to see your first year engineering subject. First year engineering subject. That is, that subject for our syllabus is called as engineering mechanics. Whatever your syllabus, if you see GATE syllabus, there you will find one subject named as engineering mechanics. But my dear students, engineering mechanics itself is a very vast branch, and that heading, engineering mechanics heading, is nothing but mechanics of rigid body, that is first year subject. And in solid mechanics, another subject is mechanics of deformable body. That too, again, this subject is called strength of material, that is SOM, strength of material, that is SOM. And this solid mechanics, that is mechanics of rigid body and mechanics of deformable body, this is the common syllabus of both mechanical engineering students and civil engineering students for GATE examination. This is the common syllabus of mechanical as well as civil engineering students. Again, in fluid mechanics, you know that fluids are of two types. Fluids basically are of two types, that is liquid is a fluid and gases are also fluids. Gases are also fluids, right? Now, in this fluid mechanics subject, that is in this fluid mechanics subject, first subject is for liquids, that is called fluid mechanics. That is called fluid mechanics. That is second year engineering subject. Fluid mechanics is basically for the liquids only, not for gases, right? And this is common syllabus of both mechanical engineering and civil engineering students, that is fluid mechanics. And in fluid mechanics, we will see only liquids. And second subject is for gases. For gases, there is a subject called thermodynamics, and this subject is only for mechanical students, only for mechanical engineering students, right? This subject is only for mechanical students. That means in engineering mechanics, there are three major subjects. Those are this is common syllabus of civil and mechanical, that is mechanics of rigid body, mechanics of deformable body, and fluid mechanics, only for liquids, right? Now, in this heading, in this engineering mechanics heading, that is I am writing here engineering mechanics heading, we are going to see mechanics of rigid body. Engineering mechanics heading, we are going to see mechanics of rigid body, right? Firstly, we will see what is rigid body and what is deformable body. First, we will see what is the meaning of rigid body. My dear students, rigid means undeformable. Rigid means undeformable body. Undeformable body is called rigid body. That means if I consider one body, let us say if I consider one three-dimensional body, let's say this is a body. Body means three-dimensional, it is having three axes, right? Let us say this is the body. Now, for this body, let us say this is a x dimension. Horizontal dimension is x dimension. Vertical dimension is y dimension. Vertical dimension is y dimension. And this dimension, thickness is called z dimension. And let us consider on this body, if I apply forces, if I apply force along x axis, if I apply force along y axis, and again, if I apply force along z axis, force along z axis, means on this rigid body, I am applying forces in different direction. Whatever may be the number of forces, apply any number of forces. Here I am applying three forces, that is force along x, force along y, and force along z axis. Now, rigid body means even due to application of forces, here I have applied forces, force along x, force along y, force along z. Even after application of forces, body will not deform. That means undeformable. That means number one, no dimensional changes, no dimensional changes, dimensional changes. This is meaning of undeformable. No dimensional changes means that is change in x is zero. Recorded lectures also, and live doubt clearing lectures also. Don't worry about that. we will cover 100% syllabus, right? Now come to the point. Undeformable means no dimensional changes. That means x dimension will not change, y dimension will not change, z dimension will not change. And second is no volumetric changes. No volumetric changes. No volumetric changes. That means volume will not change. Volume do not change. That is, change in volume is zero. Change in volume is zero. See, del is nothing but change. Del is nothing but change. And change is nothing but final minus initial. Change is always final minus initial. Final minus initial. And in this engineering mechanics subject, we are going to see rigid body. Rigid body means even after application of set of forces, the body will not deform. That means there is no dimensional change, as well as there is no volumetric change in the body. That means the final and initial dimensions are same even after application of forces. This is the meaning of rigid body mechanics. And deformable body. Second is deformable body. Deformable body mechanics. Deformable body mechanics. That is nothing but strength of material. This is second year engineering subject. Deformable body mechanics. That is second year engineering subject. Right. Now, deformable body mechanics means after application of forces, body will deform. After application of forces, body will deform. Let us consider, here I am drawing one body. Here I am drawing one body, three-dimensional body. Right. Body means it is having volume, that is three dimensions. If I consider this body, let us say, if I consider this body, now for this body, here I am giving dimensions. Let us consider horizontal dimension as a x dimension, horizontal dimension as a x dimension, vertical dimension as a y dimension, and thickness as a z dimension. These are the dimensions. And if I apply forces on this body, if I apply forces on this body, let us say force along x axis, again force along y axis, again force along z axis. Here I am applying forces along different directions on the body. Now, deformable body means after application of forces, body will deform. There will be dimensional changes. Number one, deform means the number one, dimension changes. There will be dimensional changes. Dimension changes. Dimension of body changes. That means change in x is not equal to 0. X axis will change, right? Change in y is not equal to 0. That means y dimension also changes. And change in z is not equal to 0. That means z dimension also changes. This is called dimensional changes, right? Second point. Second point. After application, yes, yes, classes will be every day. Classes will be every day. Don't worry about that. Live classes will be every day. There will be a live doubt clearing session, and we will provide you recorded lectures also, right? Now, deformable body means dimension changes. That is, change in x is not equal to 0, change in y and change in z is also not equal to 0, means dimension will change. And second point, volume. Regarding volume may change. Listen carefully. Volume may change or may not change. May change or may not change. May not change. Listen to this point carefully. For a deformable body, it is not compulsory that volume will change. Volume may change or may not change. For example, number one, for volume, number one, Poisson's ratio. There is a concept of Poisson's ratio in strength of material. Right. There is a concept of Poisson's ratio represented by mu in strength of material. Poisson's ratio is nothing but lateral strain divided by linear strain. Lateral strain divided by linear strain, that you are going to see in strength of material subject. And this Poisson's ratio, range of Poisson's ratio is 0 to 0.5. That again we are going to derive why Poisson's ratio is between 0 to 0.5 in strength of material subject, right? Now, for deformable body, if Poisson's ratio is 0.5, that is the maximum value of Poisson's ratio. If Poisson's ratio is 0.5, that is the maximum value of Poisson's ratio, then volume of body do not change. It is called undeformable. It is called incompressible body. It is called incompressible. Volume do not change means incompressible, but it is deformable body. That means dimensions are changing, but volume is not changing. And second is if Poisson's ratio is less than 0.5, if Poisson's ratio is less than 0.5, then volume also changes. That is, change in volume is not equal to 0. Volume of body is also changing if Poisson's ratio is less than 0.5. That means it is a compressible body. That means the material is compressible, right? If Poisson's ratio is 0.5, the material is incompressible. That is, volume do not change, but dimension changes. And if Poisson's ratio is less than 0.5, that means it is a compressible body, and volume of body is also changing along with change in dimension. This is called deformable body, right? And this subject, that is mechanics of deformable body, this subject is called strength of material. This is second year engineering student. Again, this is a common syllabus of both mechanical and civil engineering students. Again, now in this series of lecture for my subject, we are going to see mechanics of rigid body. We are going to see mechanics of rigid body. That is, this subject we are in GATE syllabus. This subject is called engineering mechanics. This subject is called engineering mechanics, right? Engineering mechanics. That means after application of forces, even after application of forces, body will not deform. That is undeformable body. We are going to see undeformable bodies, right? Undeformable bodies. Even it is a branch of science. Engineering mechanics is a branch of science which deals with the study of rigid body after application of forces. Now, listen to me carefully. If I apply force on the body, what will happen to the body? What will happen to the rigid body? That we are going to see. Right. Now, this engineering mechanics or mechanics of rigid body or undeformable body, here, this subject, there are basically two major topics in this subject. Basically, there are two major topics. That is, number one is statics, and number two is dynamics. Right? Statics and dynamics. Now, these are the two major topics of engineering mechanics. Again, in statics, there are 3 to 4 topics, and in a dynamics heading, there are 4 to 5 small, simple topics. Right? Statics means even after application of forces, body will not move, right? Even after application of forces, if I apply force on the body, that means there is a force on the body, but there is no motion in the body. Even after application of set of forces, body will not move. This is called statics. The body is at rest. Statics means body is at rest. This is called statics. And under heading of statics, there are 3 to 4 topics, such as equilibrium of forces. This is the first topic. Then under statics, we have friction for static. Then we have trusses. There are these few topics under the heading of statics. Means even after application of forces, the body will not move, or the body is at a rest. This branch of engineering mechanics is called statics. And second is dynamics. Dynamics means after application of forces, that means there is a force on the body. There is a force, yes. After application of forces, body starts moving. There is a motion. Due to forces, there is a motion. Dynamics means if I apply forces on the body starts moving. This is called dynamics. Means the body is not at rest, body is moving, right? Now, these are the basically two topics of engineering mechanics. Now, under the heading of statics, we will see equilibrium equations, then we will see friction for statics, and then we will see stresses. Stresses means there are forces in the member, force calculation in the different members. And under the heading of dynamics, there is a motion analysis. As due to application of force, as body is moving, means we have to do motion analysis. Again, there are few topics in dynamics. We will see again friction, that is during motion what is the friction. Then we will see work energy principle. Then we will see work energy principle. Then we will see impulse momentum principle, right? We will see impulse momentum principle also, impulse momentum principle in dynamics principle. Then we will see linear motion, types of motion, linear motion, circular motion, circular motion, plane motion. Plane motion means linear plus circular together, right? We will see linear motion, circular motion, plane motion. We will see rotation, we will see rotation. For rotation we will calculate mass moment of inertia, right? All these. Then we will see linear motion. Linear motion is due to force. Circular motion due to the torque. That means we have to see torque also, we have to see force also. Then we have to see plane motion, that is example is rolling. Plane motion, for plane motion example is rolling, that is rolling of football. The motion of football is plane motion. The football is moving in linear direction as well as it is rotating or circular, having circular motion. Or the motion of wheel, motion of wheel of car. Wheel of car is rotating or having under circular motion, as well as it is moving forward, means it is under linear motion also. Such type of motion is called plane motion, right? Now these are the two major topics of engineering mechanics, that is statics and dynamics. Again, under heading of statics there are three topics. Under heading of dynamics there are 4 to 5 topics, and this is the total engineering mechanics. Now this subject we are going to see in this series of lectures. Now, very important, what is the weightage of this subject? What is the weight of this subject or weightage of this subject for different competitive exams, right? Firstly, this course is for GATE. Therefore, firstly, I will dictate or I will tell you about GATE examination. GATE, for the GATE examination, this subject will be for 3 to 5 marks every year. This subject will be for 3 to 5 marks every year. And again, there is 100, I guarantee you, you will score 100% in GATE examination by attending all the lectures. That again, recorded lectures, see live doubt lectures, as well as go to the all the test series, right? In statics, whether the body exhibit friction, yes, in static also there is a friction, don't worry about that. Because I will tell you one example. Who is this? Mathi Wathani. Okay, in statics there is also friction. Try to pull your table, whatever table you are sitting or whatever chair you are sitting on. Try to pull that. Immediately the table will not move. Means it is under static friction. If you apply force and if body do not move, it is a static friction. If you apply force and if body starts moving, then there is a dynamic friction, right? Friction is in both, static friction also there and dynamic friction also there. In friction topic we will cover this in detail, don't worry about that. Okay, now forget weightage. Regarding weightage, forget, the subject is for 3 to 5 marks, that is mechanics of rigid body, sorry, I am talking about mechanics of rigid body only. And if you see for ESE, engineering services examination, or it is also called Indian engineering services prelims, right? Prelims, this exam is conducted by UPSC. Every year this exam is conducted by UPSC. GATE is conducted by IITs. GATE is conducted by various IITs, and ESE or IES is conducted by UPSC. For why I am saying the weightage of this subject for ESE, because syllabus is common. 100% syllabus is common. Whatever syllabus you are preparing for GATE, with same syllabus or with same preparation, you can solve each and every question of ESE prelims for engineering mechanics. For this subject, the weightage is 18 to 22 marks for prelims, right? Means very good weightage for both examinations. For both examinations, it is very having very good weightage. Again, this subject is a basic subject for understanding of strength of material. This subject is very basic subject for proper or better understanding of strength of material. All the basics, all the statics statics basics are required for strength of material. Again, for mechanical students, there is a subject called theory of machine. For mechanical student, there is a subject called theory of machine. For this theory of machine, all the basics of dynamics, are required to understand properly theory of machine. Right. Again, for civil students, strength of material, all the basics of statics are required. Then structural analysis, SA. For civil student, there is a subject called structural analysis. All the basics of statics are also required. Again, for civil engineering students, for many state government jobs, this subject is included. And again, you have to study both statics and dynamics for each and every competitive exam. Right. I hope you are getting the importance of this subject. This subject is there for each and every competitive exam of state government. This subject is there for gate examination. This subject is there for ESC, that is conducted by UPSC prelims, right? And having very good weightage. Hence, you cannot skip this subject. You have to prepare this subject. Otherwise, for further subjects, you will feel difficulty. This is the primary subject of mechanical engineering students and civil engineering students, right? So we will start for the subject. That is mechanics of rigid body. Engineering mechanics, that is mechanics of rigid body. Now, this subject is classified into two branches. Engineering mechanics is classified into two branches. Already we have seen, that is, one is statics, and other is dynamics. These are the two branches of engineering mechanics. Now, static means if I apply force, even after application of forces, body is at rest. Static means even after application of forces, body is at rest. And dynamics means after application of forces, body starts moving. There is a motion in the body, right? That we have seen. Now, we have to define what is the force. We are continuously saying now, after application of forces, if body is at rest, it is called statics. After application of forces, if body starts moving, it is called dynamics. Then we have to understand what is the meaning of force. What is the meaning of force? That we have to understand. Now, force is that quantity which changes or tries to change the inertial state of body. Force is that quantity which changes, here I am writing, which changes or tries to change, which changes or tries to change the inertial state of body. Force is that quantity which changes or tries to change the inertial state of body. Now, we have to understand what is the meaning of inertial state. Let us understand what is the meaning of inertial state. Let us consider one body. Let us consider this is the body, and this body is at rest. I am considering this body is at rest. This is my consideration. Now, rest means the velocity of body is zero. What is the meaning of rest? The velocity of body is zero. Now, this is the inertial state. This is the inertial state of body, that is velocity is zero. Inertial state is velocity is zero, that is body is at rest. This is the inertial state of body. And if I apply force on the body, then the body will try to move or body will move. Try to understand, students, what I am saying. Force is that quantity which changes or tries to change the inertial state of body. Now here I have applied force on body which is at rest. Then due to this force, the body will start moving. There will be a motion, or body will try to move. Right. Try to move means body is at rest, but the body is trying to move. Body is not yet moving, but body is trying to move. This is called change in inertial state. Or body will move, means there is a motion. This is called change in inertial state. Or let us consider body is in motion. Another inertial state I am considering here. Body is already in motion. This is another inertial state. Now let us say body is moving towards right with some velocity v. Body is moving towards the right side with some velocity v. right? This is inertial state of body, that is body is moving with velocity v towards right. This is the inertial state of body. Now if I apply force on the body, if I apply force on the body, then the velocity of body changes. The velocity of body changes. That means inertial state of body will change. Right. Now, very important point. Here, what I am considering, body is under motion and I am applying force on the body. If body is under motion and if I apply force on the body, then velocity of body will change. And if force and velocity are in same direction, if force and motion are in same direction, then velocity of body will increase. Let us consider, let us say if I consider this body, and this body is moving towards right with some velocity v. This body is moving towards right with some velocity v. And if I apply force towards right, that means initial inertial state was body is moving towards right, and I am applying here force towards right also, right? Therefore, for this case, velocity of body will increase. For such type of forces, velocity of body will increase. If motion and force are in same direction, then velocity of body will increase. Such type of forces are called accelerating forces, or such type of motion is called accelerating motion. This is acceleration. If velocity is increasing, this is called acceleration. Body is accelerating. And let us consider, if I consider body and the body is moving towards right, motion is towards right, and if I apply force towards left, if I apply force opposite to the motion, here I am applying force opposite to the motion, then velocity of body will decrease. Velocity of body will decrease. And such type of motion is called deceleration or retardation. Retardation is nothing but deceleration or negative acceleration. If velocity of body is decreasing, then it is called negative acceleration or deceleration or retardation. If motion and force are in opposite direction, then velocity of body will decrease. That means inertial state is changing, and such type of motion is called retardation. Right. Now I have explained here force. Force is nothing but the force is that quantity which changes or tries to change the inertial state of body. Right. If I apply inertial state is nothing but if body is at rest. Initially, I have explained if body is at rest and if I apply force on the body, then the body will try to move or body will move. And second point, if body is moving with some velocity v, and if I apply force on the body, then velocity of body changes. Right. And this change in velocity is given by Newton's second law that we are going to see. Here someone mentioned that Newton's law. Newton's all three laws we will see. Newton's first law, Newton's second law, Newton's third law. All the three laws in detail we will see. Don't worry about that. Here we are seeing, looking for the basic concepts. Now this force is a vector quantity. Force is a vector quantity. Vector quantity. I hope everyone knows about the vector quantities. What is the meaning of vector quantity? That everyone knows, I hope. Right. Now, vector quantity. What are the different quantities? Firstly, we will define quantities. What are the quantities in engineering mechanics? Quantities. Right. We will define what are the different types of quantities that we are going to see in engineering mechanics. Now, first, quantities. Number one, there are scalar quantities. There are scalar quantities. Scalar quantity means, to define scalar quantity, only magnitude is sufficient. Only magnitude is required to define the quantity. Right. Only magnitude is sufficient to define scalar quantities. For example, distance. Distance is a scalar quantity. Speed is nothing but distance divided by time. Speed is nothing but distance divided by time, and which is nothing but scalar quantity. Speed is a scalar quantity. Again, energy, any kind of energy, my dear students, any kind of energy. It may be a kinetic energy, it may be a potential energy, it may be a chemical energy. or whatever maybe it may be a internal energy, or it may be a electric current or electricity, right? Electric power, whatever may be the type of energy, all the types of energies are scalar quantities. Again, pressure, pressure is scalar quantity, pressure is scalar quantity, right? Remember, distance and speed are scalar quantities. Distance and speed, speed is nothing but distance divided by time. Then temperature, temperature, scalar quantity. Now I have already stated that energy is a scalar quantity. Then under energy, electric current or electric power is also energy. Electric power is also energy, electrical energy. Therefore current is also scalar quantity. Current is also scalar quantity. For examination point of view, there is a debate between, for current there is a debate, either it is a scalar or it is a tensor quantity, either it is a scalar or it is a tensor quantity. But for your examination you have to write that current is a scalar quantity. If there is a question, then current you have to write as a scalar quantity, right? Now second type of quantities, second type of quantities are vector quantities. There are three types of quantity we are going to see. We are going to see scalar, vector and tensor quantities, right? Now second quantity is vector quantity. Vector quantity means to define quantity we need one magnitude, we need one magnitude, and we need one direction. To define vector quantity we need one magnitude and we need one direction, one direction. Now for example, force is a vector quantity, force is a vector quantity. Then displacement, then displacement is a vector quantity. My dear students, already I have stated that distance is a scalar quantity. Distance and displacement are different meaning, having different meaning. That too again we will see in engineering mechanics in detail. Whenever we are going to start dynamics, just start of dynamics, we will differentiate what is distance and what is displacement, right? Displacement is a vector quantity. Then velocity, velocity, velocity is nothing but displacement divided by time. Velocity is nothing but displacement, displacement divided by time, and it is a vector quantity. Speed is a scalar quantity, velocity is a vector quantity. Again, moment, moment, force into perpendicular distance, it is a vector quantity. Again, momentum, momentum, momentum is nothing but product of mass and velocity. Product of mass and velocity is nothing but momentum, it is a linear momentum. Momentum is a vector quantity, right? Acceleration, acceleration is a vector quantity, right? Vector quantity means to define vector quantity we need magnitude and we need direction. Force is a vector quantity, displacement, acceleration, velocity, momentum, moment. These are the vector quantities. Again, third type of quantities. Third type of quantities are tensor quantities. Tensor quantities. Tensor quantities. Means tensor quantity means to define these quantities, we need magnitude. To define tensor quantity, we need magnitude, we need direction, we need direction, as well as we need plane on which the quantity is acting. To define tensor quantity we need magnitude, we need a direction, as well as we need plane on which it is acting. Plane means face. It is also termed as, or it is also called as face on which it is acting, or it is also called as area on which it is acting. It is also called as area on which it is acting, or face or plane on which it is acting. Also, tensor quantities means we need many magnitudes. Simply we can say we need many magnitude and many direction, many direction to define the tensor quantity. To define tensor quantity we need many magnitude and many direction, or we need magnitude, direction, and the phase on which the quantity is acting. This is called tensor quantity. And these tensor quantity you are going to see in strength of material. Example, for example, stress. Stress is a tensor quantity. Then strain is a tensor quantity. Strain is a tensor quantity. Then area moment of inertia. Area moment of inertia, I, written as I. It is a tensor quantity, right? Stress, strain, area moment of inertia, these are the tensor quantities. Now see my for example how it becomes tensor, that I will explain here, right? Scalar means only magnitude is sufficient to define quantity. Vector means one magnitude and one direction is required to define the quantity. Tensor means we need magnitude, direction, as well as plane on which or the face on which the quantity is acting. Right. For example, stress, strain, moment of inertia. These are the tensor quantities. Stress is a second order tensor. Stress is a second order tensor quantity. Second order tensor quantity. Now, firstly, what is the meaning of magnitude? What is the meaning of magnitude? Magnitude is nothing but anything from 0 to infinity. Anything between 0 to infinity is considered as magnitude. Now, direction. What is the meaning of direction? Direction is nothing but there are three directions, na? X direction, Y direction, and Z direction. These are the different three directions. And plane, plane or face we have to define. Plane or face we have to define for the tensor quantity. Here I am defining plane or face. Let us consider for defining plane and face, I am considering here three-dimensional element. Here I am considering three-dimensional element. Let us consider this is a cube. Let us consider if I consider cube, right? For this cube, if I draw x-axis, see this is the x-axis of cube. This is the x direction for the cube. Now y direction. This is the y direction for cube. Vertical is y direction for the cube, and z direction thickness. This is the z direction for cube. Axis towards you. Horizontal axis we are considering as a x-axis. Vertical axis we are considering as a y-axis, and axis coming towards you. Axis coming towards you we are considering as a z-axis, and x, y, z are mutually perpendicular to each other. X, Y, Z are mutually perpendicular to each other. There is a 90-degree angle between X, Y, Z. Any two axis, there is a 90-degree angle. Right. Now this is how we are defining axes. Now we will define directions. Now, sorry, faces. We have to define face. The area, the face which is perpendicular to x-axis. See here, the face which is perpendicular to x-axis. Here I am hatching with green color. The hatching area with green color. The face which is perpendicular to x-axis is called x-face, or x-plane, or it is also called x-plane. The face which is perpendicular to x-axis is called x-face or x-plane. Now, the area or the face or the plane which is perpendicular to y-axis, see here I am hatching with blue color, is called y-face. The blue hatching, this face is called y-face. This is a y-face or y-plane, or it is also called y-plane or y-face. Now again another, here I am hatching with yellow color. The area or the face or the plane which is perpendicular to z-axis, is called z-face, z-face or z-plane. It is called z-face or it is called z-plane. This is how we can define faces or planes. The face which is perpendicular to x-axis is called x-face. The face which is perpendicular to y-axis is called y-face. The face which is perpendicular to z-axis is called z-face. Now, stress tensor. We are going for stress tensor. Now, stress is a tensor quantity, and tensor quantity is written like this: sigma x x. Now, if I write sigma x x, the first letter x is for face or the plane on which it is acting, right? First letter is for face or plane, and second letter is for direction. There are two suffixes. First suffix is for face and second suffix is for direction. Now, if I write tau yz, means it is a shear stress on y face. In a z direction. This is the meaning, in z direction. This is how we are going to define. Now, we will draw stress tensor. Stress is a tensor quantity, and why it is a tensor quantity, that we are going to see. Now here I will show you stress tensor. Now let us consider again three-dimensional element. Here I am considering three-dimensional element, the same cube. I am drawing here. Here I am considering the same cube. Let us consider this is a cube, right? Now on this cube, if I there are stresses. Stresses are basically two types. Stresses are basically two types. If stress is perpendicular to area, then it is called normal stress. Then it is called normal stress, represented by sigma. And if stress is parallel to the area, then it is called shear stress. It is called shear stress and represented by letter tau. Represented by letter tau. Right. If stress is perpendicular to the area, it is called normal stress. And if stress is parallel to the area or tangential to the area, then it is called shear stress and represented by letter tau. Right. Now here I am representing the stresses. Let us consider, if I draw one stress like this, see, this stress is, can I say this stress is perpendicular to the area? Yes, obvious, anyone can say this stress is perpendicular to the area. If it is perpendicular to the area, that means it is a sigma, normal stress. Now, this is a x phase or not? This phase is a x phase, already stated. X phase means it is acting on x phase, first letter for phase. Now what is the direction? It is the x direction or not? Means it is a sigma xx. It is called sigma xx, x phase, x direction. Again, second, see, if I draw like this, if trace is drawn like this is perpendicular to area or not? This is the perpendicular to the area, right? This is a perpendicular area, means normal, sigma. And this face is y face or not? This is a y face or not? This is a y face, means on y face, first letter is for face. And this is the y direction. In y direction, sigma yy, sigma yy. Again, if I draw like this, again, see, this is perpendicular to the area, this is perpendicular to the face, means sigma. Now this is z face or not? This is a z face, means it is acting on z face, first letter for face, sigma z. And in z direction, therefore this is sigma zz. This is sigma zz. Right. Now here I have represented you normal stresses. I have represented you the normal stresses. Now I will show you shear stresses. On the same, I will show you shear stresses. Now let us consider, now already you know the faces. Let us consider this parallel stress, red color, this parallel stress. Now see, this is on x face and parallel. Parallel means shear. This is tau. Now this is on x face and going in y direction. Therefore this is tau xy. This is tau xy. Let us consider another parallel stress. Let us consider another parallel stress. This is the parallel stress. Right. Again, parallel means tau, shear. Right. Again, on x face in z direction. First letter is face, another letter is direction. X face, z direction. Now, if I consider like this, see, if I consider like this is again parallel, means tau. On y face in x direction. On y face in x direction. If I consider parallel stress like this, now this is tau. Parallel means tau. On y face going in z direction, tau yz. Again, let us say z face. On z face, if I draw like this is a parallel or not? Parallel means tau or shear. On z face going in x direction. If I draw like this, this is parallel, means tau. On z face in y direction. On z face in y direction. This is how 3D stress tensor is shown. Now stress is a tensor quantity, na? Now tensor quantities are represented in matrix form. Here, if I consider one small element, consider any face. My dear students, consider any face. See x face. You can see x face. What are the stresses on x face? There is one normal stress, sigma xx. There are two shears, that is tau xy and tau xz. These are the two shears, na? Means on any one face, there is one normal stress and there are two shear stresses. Are you getting this? On any one face, there is one normal stress and there are two shear stresses. If you consider y face, there is one normal stress, sigma y. On y face, there is one normal stress, sigma y, and there are two shear stresses, that is tau x and tau yz. If we consider z face, if we consider Z phase, there is one normal stress, sigma ZZ. There is one normal stress, sigma ZZ, right? And there are two shear stresses, tau ZX and tau ZY, right? And this stress tensor is written in matrix form. My dear students, this stress tensor is written in matrix form, right? This stress tensor is written in matrix form. This is how matrix is given. This is a square matrix, 3 by 3. 3D element, na? 3D loading, 3 by 3 matrix. For 3D loading, it will be a 3 by 3 matrix. Now, how to represent this stress tensor? How to represent this 3D stress tensor? Now, diagonal elements. My dear students, understand carefully. Diagonal elements are normal stresses. These diagonal elements are normal stresses, normal stress components, and off diagonal elements are shear stresses. Off diagonal elements are shear stresses. Diagonal elements, there will be normal stress. Off diagonal element, there will be shear stress. Now we will draw the 3D stress tensor. Properly see the diagram and understand the diagram. Here I am writing 3D stress tensor. The meaning of this diagram, which is bracketed, meaning of this diagram is nothing but I can simply draw one matrix. Or write down matrix like this. Now stress tensor, tensor quantity, that's why stress tensor is nothing but equal to, now it is written in matrix form. First row is for x phase, second row is for y phase, and third row is for z phase. And diagonal elements must be normal stresses. Now see here, sigma xx, then tau xy, then tau xz. X phase elements, first suffix is for phase, no. Now second row is for y phase, and diagonal elements are normal stresses. Off diagonal are shear stresses. Therefore tau yx, sigma yy, and tau yz. Then z phase, tau zx, tau zy, and sigma zz. This is how 3D stress tensor is represented. Now here I am showing you on the screen whatever the diagram, this diagram is also represented as matrix form, like this, right? This is a 3D stress tensor. Now stress, I have already stated that stress is a tensor quantity. Now for example, here I will provide you how stress becomes tensor quantity, that I am going to tell you. Now here I am drawing stress tensor, right? What is the stress tensor? If I draw this stress tensor, or in previous diagram only, I will take previous diagram only. Here in this 3D stress tensor, see my dear students, if I give you one value, or if I dictate you one question, see the question is that what is the if stress on the component is 10 megapascal. Question I am dictating here, stress is equal to 10 megapascal. Now what is this? Stress is equal to 10 megapascal. What is this? Magnitude or not? This is magnitude is given. Now tell me, out of these 9 stresses, what is the 10 megapascal value? Which value I am providing here? Out of these 9 stresses, which value I have provided here? I have given that stress is equal to 10 megapascal. Which value I have provided? It is not sufficient data. I cannot say. It can be any value out of these 9 values. Therefore, only magnitude is not sufficient. Here I will provide you direction also. In x direction. Now what I have given? I have given you one magnitude and I have given you one direction. Am I correct or not? Here I have given one magnitude 10 megapascal. I have given you direction in x direction. And if you properly or carefully observe the diagram, then see sigma xx along x direction, tau xz along x direction, and tau yx along x direction. Means along x direction there are three stresses. Along x direction there is sigma xx also, there is tau yx also, and there is tau zx also. Means again this 10 megapascal in x direction, I cannot say which value is given. There are again confusion between three values or three stresses. Out of these three, any one is provided. Means with only magnitude and direction, it is not sufficient to define stress. And if I define phase also on y phase, here I have defined one magnitude 10 megapascal, defined direction x direction, and on y phase is also given. That means it is tau y phase z x direction y phase and x direction. This is or not? This is tau yx is equal to 10 megapascal. Tau yx is equal to 10 megapascal. That means here to define stress, see here in stress tensor, if I see stress tensor, the magnitude is stress is equal to, what is the question? Stress is equal to 10 megapascal on x on y phase. What is question? On y phase in x direction. Means here I have provided direction, I have provided phase, I have provided magnitude. Then I can say tau yx is equal to 10 megapascal. Tau yx is equal to 10 megapascal. That means this value is given. Tau yx, this value is given. Means to define stress, we need magnitude, direction as well as phase. Hence, stress becomes tensor quantity. Hence, stress becomes tensor quantity. Now, my question is that I have already stated that pressure is a scalar quantity or not. Pressure is a scalar quantity and stress is a tensor quantity. Now, my question to you is that why pressure is a scalar quantity and why stress is a tensor quantity already explained. Now, why pressure is scalar quantity? Can anyone comment? Can anyone give comment or provide me answer? What is the question? Stress is a tensor quantity, pressure is a scalar quantity. Already I have explained that pressure is a scalar quantity. Already I have explained that pressure is a scalar quantity. Pressure is a scalar quantity, that is remaining part. But already I have explained that stress is a tensor quantity. Now stress is a tensor quantity, but pressure, it is a scalar quantity. Why this is so? Why this is so? This is a very basic difference between stress and pressure. You have to understand properly. Okay, it's not any particular direction. Okay, half correct. Pressure is on all direction. Pressure is acting on all direction. Now see, this is for interview point of view. Difference between stress and pressure is very critical point. There are four basic differences. There are four basic differences between pressure and stress. Now we will define pressure. Firstly, we will define pressure. Pressure is nothing but pressure. Pressure is nothing but force divided by normal area. Force divided by normal area. Normal area. This is the definition of pressure. Dear students, don't say force divided by area. Don't say force divided by area. Pressure is force divided by normal area. Normal is nothing but perpendicular. Normal is nothing but perpendicular area. Right. Pressure is nothing but force divided by normal area. Now, in it, force is nothing but Newton. Area is nothing but meter square. Newton per meter square is nothing but Pascal. Newton per meter square is nothing but Pascal. Now pressure. See, what is the Pascal law? What is the Pascal law? Everyone knows this law. Mechanical, civil, both branch students, everyone knows this law. This is very basic law. Pascal law is nothing but for static fluid, this is very important. For static fluid, at a point, pressure in all direction, pressure in all direction is same and compressive. This is the complete statement of Pascal law. Pressure for a static fluid at a point, pressure in all direction is same and compressive. Let us consider, if I consider one vessel, and if there is a water in this vessel, let us say this is a water in this vessel, means it is a static fluid. In this vessel, the fluid is under static condition, rest condition. And if I consider one small 3D element in this vessel, if I consider very small 3D element in this vessel, let us consider one 3D element. Let us say this is small element, very small point. We can say this is a point also in this vessel. Now, pressure at a point in all direction is same and compressive. Means Pascal law says that in x direction pressure is P, in y direction pressure is P, in z direction also pressure is P. Means in all the three direction pressure is same and compressive. Means if I give you one example, pressure is equal to 10 megapascal. Now tell me, in which direction? Here I have provided you the value of pressure is equal to 10 megapascal. Now in which direction? In all direction. No need to define again direction. In all direction, right? As per Pascal law, it is in all direction. On which face? On all faces. Again, see, it is acting on all the faces or not? It is acting on all the three faces. Therefore, again, no need to define direction, no need to define face. It is acting on all the faces, acting in all the directions, right? Again, no need to define separately face and direction. Means only magnitude is sufficient. Hence, pressure is a scalar quantity. Pressure is a scalar quantity, right? Now what is the difference between stress and pressure? We are going to see what is the difference between stress and pressure. Write down heading, difference between stress and pressure. Before this I will define stress and I will define pressure. Pressure already we have defined. Pressure is nothing but force divided by normal area. Pressure is nothing but force divided by normal area. Now what is the stress? What is stress? Stress is nothing but resisting force per unit area. Stress is nothing but resisting force per unit area on which the force is acting. Am I correct or not? Stress is nothing but stress. Here I am defining stress. Stress is nothing but it is resisting force per unit area on which the force is acting. Per unit area on which the force is acting. Again, resisting force in Newton, area in meter square, means same unit Pascal, same unit like pressure, that is Pascal. Let us consider if I consider one element and having cross-sectional area as a circular. Let us say if I am considering this element having cross-sectional area. Here I am hatching area with red color. This is the area on which I am applying force. On this red hatching area, I am going to apply force. And let us consider force is applied like this. Force P is applied like this. Now this P is applied force. My dear students, P is applied force. P is not resisting force. P is applied force here, applied on circular cross-section area A. Now, because of this force, the bar will try to deform. It is a strength of material subject. Now, in strength of material, stresses are calculated in strength of material, no? Therefore, in strength of material is nothing but deformable body. Therefore, for this applied force P, the body will try to deform. And for this deformation, the body will offer resistance. for this deformation, the body will offer resisting forces. R is resisting force. R is resisting force. And this stress is nothing but due to resisting force and divided by the area on which force is applied. What I am saying, area on which force is applied, means stress is always due to the resisting force and not due to the applied force. Are you getting or not? Stress is always due to the resisting force. Stress is never due to the applied force. Right? It is because of the resisting force. Now, but as per Newton's third law, for every action there is always equal and opposite reaction. As per Newton's third law, for every action, our action is applied force P. There is always equal and opposite reaction. Reaction is nothing but resistance here. Therefore, stress can be written as resisting force divided by area or applied force divided by area on which this force is applied. Area on which this force is applied. This is how stress is defined. But the primary definition of stress is because of resisting forces only. Stress is never due to the applied force. Write down this note. Stress is never due to the applied force. Stress is because of resisting forces only. Right. Now this is the definition of stress. And stress can be in strength of material. You are going to see normal stresses. That is normal stress. There will be a tensile stress, there will be a compressive stress. If normal stress, in normal stress, if load is applied perpendicular to the area, normal stress means load is perpendicular to area, and if applied load is tensile, let us say this is a tensile to the area, then this is tensile stress. And stress can be compressive also. In normal there will be compression also. Let us say on area, just a minute. Okay, stress can be compressive also. If force is applied compressive, then stress will be compressive. Sigma c. Stress will be compressive. Right. This is called normal. Tension and compression are normal. Right. What is the question? What about the point at surface of liquid? Surface of liquid, it is under surface tension. Right or not? Surface of liquid is nothing but, there is a one question, what about the point at surface of liquid? Surface of liquid means, let us say, here I am drawing the diagram. Let us say this is a liquid. This is a liquid, right? And this is the surface of liquid. And above the surface there is a gas. Above the surface there is a gas. And gas and liquid are immiscible fluids. Gas means air. There may be a air. Gaseous state, there may be air. Right? Air and liquid are immiscible fluids. And whenever there are two immiscible fluids in contact, there is a surface tension. It is called surface tension. Right? The surface of liquid is nothing but under tensile action. That is surface tension. And this surface tension is considered as negligible tensile force due to immiscible fluids. What I am saying, negligible tensile force due to immiscible fluids. Right? Okay. Akash, the video will remain. Don't worry, the video will remain on YouTube. You can go back and you can see. Or else at the end, I will explain this. Don't worry about that. Now, whenever two immiscible fluids are in contact, there is a surface tension. At the contacting surface. Right. Now, stress. Come back to the stress. Stress can be normal. Under normal, the stress can be tension. Means if tensile force is applied, tension. If compressive force applied, compression. Under normal, there is tension and compression. As well as stress can be shear. Also. Right. Now, go to the difference between stress and pressure. Right. Here I am writing difference between stress and pressure. You also write down, make a difference column, that is write down one side stress and one side pressure. Right. Number one, difference between stress and pressure. One side I am writing pressure. Pressure is nothing but, it is nothing but force divided by area, na? It is nothing but force divided by area, and unit is Pascal, Newton per meter square. Stress is also force divided by area. It is also force divided by area, and unit is also Pascal. Unit is also Pascal. The first difference between stress and pressure. The first difference between stress and pressure is that, number one, pressure is nothing but force divided by, pressure is nothing but force divided by normal area. Normal area. My dear students, for pressure calculation, always we have to consider perpendicular area. Perpendicular is nothing but normal area. Right? It is force divided by normal area. And definition of stress. Stress is nothing but resisting force. For stress calculation, we have to consider resisting forces. We have to consider resisting forces. Therefore, stress is nothing but resisting force divided by area on which force is applied. For stress calculation, normal area is not considered always. It may be a normal area, it may be a shear area. That depends again the force on which area is the area on which force is applied. For stress calculation, it is resisting force per unit area on which force is applied. This is the first difference. Second difference, pressure is scalar quantity. Scalar quantity. Due to Pascal law, pressure becomes scalar quantity, and stress is a second order tensor quantity. It is a tensor quantity. Stress is a tensor quantity. That is second order tensor quantity. Now, third difference, already I have explained scalar and tensor quantities. Right. If someone is having confusion in scalar and tensor quantity, you can rewind this video. Go back. पीछे जाके देखो. पूरा explain किया है पीछे. Now again. Now third difference, pressure is always normal and compressive. Pressure is always normal and compressive. My dear students, it is always normal and compressive. Some may say that surface tension is a tensile pressure or not. Surface tension is a tensile force acting between the two immiscible fluids or not. Dear students, this is a fluid mechanics concept. In fluid mechanics, separately that point will be covered. What is the point? If two immiscible fluids come in contact, then at the contacting surface, there is very negligible tensile force called surface tension. But the point in fluid, what I am saying, not the surface in contact. What I am saying here, the point in the fluid, on this point, the pressure is always normal and compressive. Now, for stress, stress can be normal also. Stress can be normal also. Again, in a normal, it can be tension, it can be tensile, or it can be compressive. It can be compressive. Depends on the loading, right? But pressure is always normal and compressive. Pressure is only compressive. Stress can be tensile as well as compressive. As well as stress can be shear also. Pressure is never shear. Pressure is never shear. Stress can be shear also. Right. Now, last point. Difference between stress and pressure. Pressure is applied quantity. Pressure is applied quantity. Applied quantity. Pressure itself is a applied quantity. Now, but stress is induced quantity. Stress is induced quantity. Induced quantity. Understand the difference. What is the meaning of applied and induced quantity? Properly understand this difference. My dear students, applied quantity means, consider your pen. In your hand, there is a pen. Consider this pen. What is the pressure on this pen? Tell me, what is the pressure on your pen? The pen in your hand. Anyone can say that there is an atmospheric pressure. There is an atmospheric pressure acting on this pen. What is the pressure on your mobile? The mobile phone in which you are watching this video, what is the pressure on this mobile phone? Anyone can say there is a pressure called atmospheric pressure, 1 atmosphere, right? Or what is the pressure on you? What is the pressure on you? Atmospheric pressure. Right now, the pressure on you, pressure on pen, pressure on mobile phone, or pressure on any device in your room or outside room is atmospheric pressure. Means as device changes, pressure is not changing because pressure itself is applied. Device is changing, component body is changing, but pressure itself is applied, that is 1 atmospheric. 1 atmospheric. Now what happens if device changes? What happens as component changes? Means pressure, this pressure is nothing but, understand carefully, force divided by normal area. Force divided by normal area. Therefore force becomes pressure into normal area. Pressure into normal area means on each and every component that you can see right now, the pressure is 1 atmospheric. On every component there is a pressure called 1 atmospheric. On mobile phone, on pen, on you, on your water bottle, on table, on chair, pressure is 1 atmosphere. Means pressure here is constant, applied quantity here, pressure is constant. But for each and every device, what is changing? Area is changing or not? For each and every device, pressure area is changing, means force is changing here. Here, as area is changing, the force on the component is changing. Right. Now stress, what is the definition of stress? Stress is nothing but resisting force divided by area. Means force is applied on the component. Force is applied on the component, and for this force there is a resistance in the component. See, force is applied on the component. For this force, resistance is induced in the component. Resistance is induced in the component, and for due to this resistance there is a stress. Due to this resistance there is a stress. Means stress is induced due to the resistance. Stress is induced due to the resistance. Therefore, stress is considered as induced quantity. Understand the difference, my dear students. Because of pressure, there is a force on the component. For pressure, if pressure comes in contact with area, then pressure into area becomes force. And for this force, there is a resistance. And for this, due to this resistance, there is a stress. This is the basic difference between pressure and stress. Right. Now, if anyone is having any doubt, you can ask me. Up to this point, if anybody is having doubt, ask me. Lanka Akash, you can see this video because the video will remain on YouTube. Still, if you have doubt, you can comment like this. Sri Ram, once again, what once again means which point? Viresha Nandu, what is the stress on free surface? That depends on the resistance. Which type of free surface you are saying? That depends on the resistance. Free surface means, see, I will explain that. Your point, I will explain that. Just a minute. I will erase something on screen. See, stress is due to the resisting forces. Stress is due to the resisting forces, and it is not due to the applied forces. It is not due to the applied forces, right? And if there is no resistance in the component, Viresha, if there is no resistance in the component, there will be no stress. No resistance means no stress. Means no stress. And if component is free, component free to deform. There is in question, it is basic, most of the time written that the component is free to deform or the component is free to move away. Write down the statement. I am dictating. If a component is free to deform or free to move away, or free to expand or contract due to change in temperature, temperature, then stress on the component is zero. Then stress on the component is zero. Now concentrate on this. Now concentrate on this. Whenever a component is free to deform or free to move away or free to expand or contract due to change in temperature, then stress in the component is zero. That means, let us consider, if I consider water, let us say water is flowing through the channel or river. Let us say this is a water is flowing. And if I drop one mass, let us say if I drop this mass in the water, ये मैंने उठा के इस मास को पानी के अंदर फेंक दिया. Now what will happen? If this mass falls in the water, या अगर mass गिर गया पानी के अंदर, then water will deform without any resistance. ये इधर भाग जाएगा. Water will go this side, left side, or water will go to the right side. Right? Means it is free to deform. Water is free to deform means stress in water will be zero. That will deform without any resistance. Therefore, stress in water will be zero. Or free to move away. Let us say this is a surface, smooth surface. Let us say this is a smooth surface with coefficient of friction zero. Smooth surface means coefficient of friction zero. And on this component, on this surface, if component is kept and if force is applied, this is an applied force. Dear students, this is an applied force. And coefficient of friction of this surface is zero. Means due to this, as surface is frictionless, because of this force, the component will move. There will be motion in the component. There will be no stress. There will be no stress in the component. There will be motion in the component. Means the component is free to move away. As well as if component is free to expand or contract. If temperature increases, component will expand. If temperature decreases, component will contract. And if this expansion or contraction is free, then stress will be zero. In the component, stress will be zero. I think you are getting 0.4 again. Pressure is applied quantity, stress is induced quantity, applied, induced. See, if what is pressure? Pressure is nothing but force divided by area. Now, pressure, therefore force, therefore pressure. If pressure gets area, then there will be a force. Am I right or not? Pressure into area is force, and for this force there is a resistance. For this force there is a resistance, and due to this resistance there is a stress. Due to this resistance there is a stress. Means initially you have applied pressure, and if this pressure gets area, there will be a force, and due to this force, resistance is induced in the component, and due to this resistance there is a stress. Hence pressure is applied quantity, stress is induced quantity. Okay, any other point? Okay, the classes will be daily. The classes will be daily. There will be a daily doubt session where Ekeeda is providing you recorded lectures also. You can see these recorded lectures in Ekeeda application, and for the same daily there will be a doubt clearing section, right? Okay, thank you. Download the application, Ekeeda application. Daily time varies, depends on the faculty or depends on the subject. The time varies. You can in application everything will be there. Application, Ekeeda application, download Ekeeda application. You will get timing. You get daily timing. Okay. Also, you can watch their recorded lectures. Okay, thank you. Thank you, everyone. If you have any doubt later, you can comment. Okay, take care. Yes, you can search Ekeeda. Same Same video is running on Ekeeda platform. Subscribe this channel, Ekeeda platform. Subscribe this channel. Raj, you can subscribe this channel. Bye bye. Bye bye, Sri Ram. Thank you. Welcome. Welcome, Omkar.